Okay, we're going to do basic operations with matrix. So let's multiply matrix by number. So we have matrix A that is equal 1, -2, 3, 0, 4, -1, 5, 0, 0. And we need to find 3A, meaning 3 times A. So I'm going to take this 3 and distribute by every single element in the matrix. Pretty straightforward. So it's going to be 3, -6, 9, 0, 12, -3, 15, 0, 0. Okay. Next, this is easier case. Let's take more interesting case. A is equal 1/4, 2/3, 3/7, -1/2, 0, and 3/4. And we need to get alpha times matrix A, where alpha is equal 1/8. So we have 1/4 by 1/8, it's going to be 1/32. 2/3 by 1/8, it's going to be 2/24, which is 1/12. Next, 3/7 times 1/8, it's going to be 3/56. -1/2 times 1/8, it's going to be -1/16. Here is 0. 3/4 times 1/8, it's going to be 3/32. Okay. Next, let me write down this. I'll put it here and change the color so we would see what alpha means. Next one, we have matrix A is equal 2 C and 1/B. And here I have B/4 and -B and 0. So we need to multiply matrix A by number alpha, that is equal B. Okay, so what we are getting as a result, alpha times A is going to be equal 2B, right? Because alpha equal B. 2B and then B²/4 and then BC, -B², 1 and 0, right? We multiplied B by every single term. And lastly, let me make it better way. Okay. And lastly, what we're gonna do, we are going to multiply, let me see, matrix A elements of which are x, 1, 1, 1, x squared, 1, 1, 1, and x squared, x cubed. Okay, let's take x squared, x cubed this time. Okay, so we need to multiply matrix A by alpha. Where alpha is equal x squared. So from here, alpha A is equal. So I'm going to multiply every single term, every single element by x squared. We are getting x cubed. Here gonna be x squared, x squared. Next is coming x squared, x to 4, x squared. Next is x squared, and x to power 5. So now let's move to order of addition, to addition and subtraction. It's addition and subtraction is very easy. Let me write down. Addition, subtraction. Before I start doing addition and subtraction operations of matrices, I would like to tell you that addition and subtraction operations are defined only and only for matrices of the same size. If I need to add matrix A that have size m times n, then the matrix B that I'm adding to A has to be the same size. Okay? Let me write down. So it has to be same size. M row on both matrices and n amount of columns. So, and to do addition and subtraction of matrices, it's a pretty clear operation because all we're gonna do is just add and subtract corresponding elements. So let's do it. I have A, matrix A, that is equal -1, -2, -1, and 5, 9, -8. Okay, this matrix A has 2 rows and 3 columns, right? So it's 2 by 3. Okay, matrix B we are given. It has 10, -25, 98, and 3, 0, and -14. So this matrix also has 2 rows and 3 columns. And matrix F that has 1, 0, and -5, and 4. So it has 2 by 2 square matrix. So here is what is interesting, that neither A nor B I cannot add to F because they don't have the same size of matrix, which means A plus F, it's not gonna happen. Let me write down here 2 times 3 here, and here we have 2 times 2. Size is different. In the same way, B plus F, 2 times 3 and 2 times 2. Also cannot happen because the size is different. But matrix sizes A and B coincide, which means matrix data contain the equal number of rows and columns, so the addition operation is applicable to them. All right, matrix C is equal A plus B, and that is equal -1, -2, -1, 5, 9, -8, and we are adding 10, -25, 98, and 3, 0, -14. So how we are adding? Here I have A11, A12, A13. Here I have A21, A22, A23. So the same way I am marking down here B11, B12, B13, and B21, B22, and B23. Okay? So I'm going to add A11, I'm going to add elements with the same index. 1, 1, A, I'm adding B11. A12 adding B12. A13 adding B13. Okay? And as a result, I'm going to get, this is equal, so it's going to be -1 plus 10. I'm going slow so you can see. -2 plus 25, minus 25. And -1 plus 98. Okay? And then A21, I'm adding B21. So it's going to be 5 plus 3. A22 plus B22, 9 plus 0. And I have -8, -14. And as a result, C, matrix C, is going to be equal 9, -27, 99, and then 8, 9, and -22. Okay, pretty straightforward. Now, next we want to do subtraction. Same two matrices, A and B, but we are doing subtraction. So D is equal A minus B. Exactly same principle. So we are doing -1, -2, -1, 5, 9, -8, minus 10, -25, 98, 3, 0, -14. And the result is going to be equal. So first I'm doing -1 minus 10. So -1 minus 10. And next I'm doing -2 minus -25. -2 minus -25. And then negative 1, negative 1 minus 98. So negative 1 minus 98. Okay, next. 5 minus 3. Next, it's going to be 9 minus 0. And negative 8 minus negative 14. Okay, when you do subtraction, just be careful, because if number is negative, minus, and then put, don't forget, put minus and then in parentheses negative number, because the result is going to be either addition or subtraction, right? Based on sign. Okay. So from here, what we are going to get it's going to be negative 11, negative 2 plus 25, negative 23, negative 1 and negative 98, negative 99. 5 minus 3 is 2, this is 9, and negative 8 plus 14 is going to be 6. Okay, this is subtraction. And let's close the topic of addition subtraction, but by writing down the matrix addition properties. Okay. Property number 1. A plus B is equal B plus A. Commutative property. Second one, associative property, which means A plus B times plus C is equal A plus B plus C. That's obvious because addition, it's never been problem. Add one to another first or second to and third first. So in addition to sum of matrices and their product are related by distributive property, which is going to be the third one. A plus B times C is equal AC plus BC. And let's close the topic of addition subtraction, but by writing down the matrix addition properties. Okay. Property number 1. A plus B is equal B plus A. Commutative property. Second one, associative property, which means A plus B times plus C is equal A plus B plus C. That's obvious because addition, it's never been problem. Add one to another first or second to and third first. So in addition to sum of matrices and their product are related by distributive property, which is going to be the third one. A plus B times C is equal AC plus BC. Okay, it's going to be product of matrices. Before we do product of matrices, I would like to give you some important information. Okay, let's assume I have matrix A with size 5 times 4, which means 5 is a row, right? 4 is column. First always row, second one is column. And then matrix B, I am multiplying 4 times 9. Where 4 is a row and 9 is column. Okay. So to be able to multiply matrix A on matrix B, then first we need to make sure the number of columns in the matrix A, okay, equal to number of rows of the matrix B. Okay, they have to be the same, equal. So in this case, if, for example, let me see, if we have matrix A 5 times 4, okay, and matrix F 9 times 8, we cannot multiply. Why? Because here we have 4, here we have 9. Okay? That's why we cannot multiply. But multiply matrix A 5 times 4 on matrix B 4 times 9 is possible, because the number of columns of matrix A is equal to number of row for on matrix B. Moreover, the result of matrix or multiplication A by B, it's going to be C. Let me move this away. It's going to be C, matrix C, the measurement of which, the size of which, is going to be 5 times 9. This is going to be, okay, this 5 times this 9. So this is how I usually, it's easier for me. So 5 times 4 and 4 times 9. So inside numbers has to be the same, and result is going to be outside measurement. Okay, that's how I do. Inside has to be, and from here you can guess that you cannot apply commutative rule for multiplication, right? We will get there. If you switch B times A, you would get what? 4 times 9 times 5 times 4, and you can do multiply the rest of your life and you won't get correct answer, because you have here 9 and 5. It's not the same. So you cannot apply A times B in the case of matrices is not equal B times A. Well, we will get to that. So it's crucially important. So this in the measurement, this inside numbers would be equal, which means column of one has to be equal to row of another. Then the measurement of the product matrix, it's going to be outside numbers 5 and 9. Here it is. We have 5 and 9. Okay? Hopefully this will help you to do well with this. Okay, now let's multiply how we are going to work with this. So let's assume I'm getting easy case. Matrix A is equal -1, 2, -3, 0, 5, 4, -2, 1, -8, 11, -10, -5. This is first matrix. And second matrix is B. We have -9 and 3. We have 6 and 20. We have 7 and 0. We have 12 and -4. Well, let's see. A has how many columns has, how many rows has 3, right? How many columns has? 4. B, how many rows has? 4. How many columns? 2. So as you can see, this number is equal to this number. That means A times B, this is 3 times 4, this is 4 times 2, it's going to be equal C, which going to equal with the size of matrix, it's going to be equal 3 times 2, right? Okay, so we learned all of it. Now let's follow our multiplication, how we are going to multiply. Okay, so since I'm going to get 3 times 2, then the matrix C, 3 times 2, it's going to be equal 3 rows, A11, and 2 columns, right? 2 columns, A11, A12, I mean C11, C12. And then second row, C21, C22, and third one, C31, C32. And indeed, we got 3 by 2. So we need to calculate every single number here, single element. Okay, so how we are going to multiply? Look, when you look at the first element here, C11, right? C11, listen carefully, please. I have row is 1 and column is 1. So first one, row, that's taking the row from A, because we are multiplying A times B, which means this is going to be, this first index row shows it taken from matrix A, and the second index, which is column, taken from matrix B. If we would multiply B by A, then the row for, we would take the row from B and the column from A. Okay, so C11, we are taking the row from A. So it's going to be equal -1 multiplying by -9, okay, by -9, and then adding plus. Next, I guess I could change the color here. Okay, green. Next, I'm going to do this color. So 2, second element in the first row, multiply by 6. So it's going to be 2 times 6. Next, plus we are going to have this one, -3 multiplying by 7. So first column multiplied by first row multiplied by first column, and it's gonna be -3 times 7. Yes, and the last one, it's gonna be, let me pick the color. I'll take this one. Okay, multiplying 0 by 12, and that's gonna be 0 times 12. And if you add all this, it's gonna be how much? +9 plus 12 minus 21 and 0. So plus 0. All right. So 12 minus 21. So 9 plus 21 is 21. And the answer is 0. So we have C11. Now we are finding C12. Again, we are taking first row from matrix A and multiplying now by second row of second column of matrix B. So in C11 we multiply by first column, in C12 multiplying by second column. Okay, so it's gonna be the same way. Let me see, since I have this, let me multiply the color the same way. This is gonna be this, and then I need this in green color. Okay, so let's start. First we multiply -1 by 3. So first row of matrix A multiplying by second column, because we have here 2, see? C12. Second column of matrix B. So it's gonna be, so -1. Okay, going to use green one. -1 times 3, then plus, next I'm using the blue color because I'm doing 2 times 20, okay, next I'm using this color because it's going to be -3 times 0. And lastly, I'm using purple color because we have 0 times -4. If you add this up all together, we are getting 37. Okay, so this is C12 we have. Next time I need to calculate C21. C21. So I'm taking now second row from A, multiplying by first column from B. All right, let's go. Second row, so it's gonna be 5 multiplying by first column of B, 5 times -9. Plus, what do we have? 4. Okay, this wasn't a good idea. 4 multiplying by 6, again, first column. Next, negative 2 multiplying by 7 negative 2 multiplying by 7, okay, and 1 times 12. So 1 times, which is purple, has to be 12. Okay, if you add them up, you are going to get negative 23. All right, accordingly, let me write down. So this is all gonna be also this color. Then this is gonna be this color. Okay, this one is gonna be this color, and this is gonna be green. So all green multiplied by green, blue by blue, purple by purple, and so on. Okay, we have C21. Now I need to fill out C22, right? So let me go over now. We already understand how we are doing. So second row from A multiplied by second column from B. It's gonna be, I'm going to make smaller so we can see the elements. So C22 is equal 5 times 3 plus 4 times 20 plus negative 2 times 0 plus 1 times negative 4. And this is going to be equal 91. C31. Okay, let me just fly over. Negative 8 times negative 9 plus 11 times 6. Okay. 11 times 6 plus negative 10 times 7. And negative 5 times 12. And the result is going to be 8. And the last one, C32. So first row from A multiplied by second column from B. And result is going to be negative 8 times 3 plus 11 times 20 okay, plus negative 10 times 0 okay, and lastly negative 5 times negative 4. And the result, you should get 216. I prepared not to waste time on all these calculations, simple calculations. So what is going to be our result? Let's write down. C is going to be equal, with measurement 3 times 2, with the size 3 times 2, it's going to be equal. So let's fill out. C11 is 0, C12 is 37, C21 is negative 23, C22 is 91, C31 is 8, C32 is 216. And this is going to be the product C. Okay? A times B where A is 3 times 4, B is 4 times 2. We are getting C 3 times 2, which is equal here 0.37, negative 23, 91, 8, and 216. Okay, then that is the answer. So, by the way, there is often no reason to describe in details how you find this element. All you have just to do, do the operations somewhere drafting on the side and just put the answer. Okay? And as I mentioned that matrix multiplication is non-commutative, commutative, which means A times B, it's not equal B times A by the reason I already explained. Since I wrote down one of the properties of multiplication for matrices, which means we cannot apply commutative property. Second one is if we multiply the matrix A by zero matrix, which means all elements are 0, we are getting matrix with all elements 0. And third one, unlike commutative, we can apply associative property for product, which means AB times C is equal A times BC. Okay. Next, the property number 4, we can apply distributive property, which means A plus B times C is equal AC plus BC. Okay. The property number 5, the determinant of the product of two square matrices is equal to the product of their determinant, which means if A times B is equal C and both A and B are square matrices, then the determinant of C is also equal A. And the last operation is going to be transposed matrix. Since I already covered in my previous video, I'll just bring example, okay? So the goal of transposed matrix, just switch row into column, into transposed matrix. So simply we need to put in order to get transposed matrix A to power, well, A index T, let's say. Hold on. With index T, that's mean transposed. So we need to take original matrix A, replace the column with corresponding rows according to the following principle. There was the first row, the first column will become second row, will become second column, and third row will become third column. So what does that mean? If our A matrix has size m times n. Let me rewrite. Matrix A with size m times n, and with element of this matrix A, I, J. So then transposed matrix A transposed, it's going to become n times m. Column become row, row become column, right? With the elements A, I, G transposed, which means it's going to be A, G, I. Obviously, column will become row. All right, so let me write down here transposed matrix. And I'll write down one example one more time, since we had them previously already. So if we have A is equal, let's say, -3, 0, 5, another 0, and 6. Here we have 2, -4, 20, and we have 11. Here is -5. And lastly, we have -11, -7, -1, -9, and +9. So from here, A transposed, oops, it's going to be, I'm taking this column first, the first row, and it's going to become first column, -3, 0, 5, 0, 6. Okay. Next, I'm taking second row, and it's going to become second column. Maybe it would be better if I just change the color of numbers itself. Let me do it. I think it would be better than make a mess with this highlighting. With this framing. Hold on. This is going to be green. Okay. Yeah, of course. This is going to be better like this. Much more cleaner. Next. This one, it's going to be blue. So it's going to be here 2, -4, 20, 11, -5, and the third row, it will become third column, -11, -7, -1, -9, and +9. So this is going to be transposed matrix.